This is the lab lecture video for the spectrophotometric determination of iron lab. Anything about calculations and conceptual stuff will be found in a different video on the Canvas page. So the spectrophotometric determination of iron lab is all about, well, spectrophotometric determination. So we're going to be making measurements of the absorbance of solutions that have a visible color. So the solutions in this lab that have a visible color are a complex that has iron in it. So it's an iron mixed with O-phenanthroline. This chemical reaction to produce this orangey reddish color that we're going to be making has to have the correct conditions around it. So we are working with lots and lots of solutions. So many different types of chemicals. So we're definitely wearing gloves, and we are not pouring any chemicals directly down the drain. We will have a waste beaker to contain all of our chemicals, which we'll talk about how we'll deal with those chemicals at the end of lab. So just like with any spectrophotometric determination lab, part A of the lab is always to make standard solutions that we accurately know their concentration using dilution. So for this lab, all of the solutions we're going to be making will be in 50 milliliter volumetric flasks. So you're going to need lots and lots of 50 milliliter volumetric flasks. I want to bring up again, similar to the last lab, that the 50 milliliter volumetric flasks that we have a few different types of lids that fit in them. All of them are about the same size, but what's different is which lid works for them. So we have some volumetric flasks that are clear glass all the way to the top, and those volumetric flasks need plastic snap-on lids that are either a yellow number 3 or a blue lid with a 50 milliliter written on it. So when we go to add the lid to the top of the flask, we do it using 2 thumbs, and we just press down with both of our thumbs until we hear a snap. Okay. If we put the lid on and we don't hear a snap and it feels very loose, then that is not the correct lid for that flask. So just always double check that your lid fits correctly. If your lid is, you're trying to put the lid on, but it is not, your thumbs are not able to press down onto that lid, then you probably have the wrong size lid. So if the lid is too loose or the lid seems too small and it's not working, get a different lid. Don't keep trying to force it. If you get a volumetric flask that has a ground glass top, so like this where it's kind of white at the top, then it needs a glass stopper as the lid. Okay. You can mix and match these as much as you want. So for part A, you're going to need 6 volumetric flasks. They don't all have to have the same kind of lid. Okay, so just get 6 volumetric flasks and make sure each flask you have the correct lid for it. So there is a table in the lab procedure showing how many milliliters of each solution needs to be added to these volumetric flasks. So 6 solutions are going to be made. One of them is a blank, and then standard 1, standard 2, standard 3, standard 4, standard 5. The blank solution will be just like the standards, only it will not contain the active ingredient, the solution or the chemical that we're testing. So in this case, no iron will be added. There are 1, 2, 3, 4 different chemicals to add, plus adding DI water to dilute it. So my suggestion on how to do this lab with your partner in the most time efficient way is to get all 6 volumetric flasks, label them blank, 1, 2, 3, 4, 5, and then do an assembly line. So one person say, okay, I'm going to add the iron to all of the volumetric flasks. And then the other partner can say, I'm going to add the 1 molar ammonium acetate to all of the volumetric flasks. And once you've done your chemical, and your partner has done then their chemical, well then each partner chooses a different chemical because you're pipetting 4 solutions into this. So all 4 of these chemicals, the iron solution, the ammonium acetate, the hydroxylamine hydrochloride, and the O-phenanthroline, are going to be added using volumetric pipettes. Okay. We will always use a pipette that is the exact size of the volume that is being added when we can. So we have volumetric pipettes that are 1 milliliter, 2, 3, 4, 5, 10, and 25. So on this table, all of the volumes are between 1 and 5 or a 10. So we will use a different volumetric pipette for that, unless we're using the same volume with the same chemical. So for example, the iron column on the table has 0 milliliters added to the blank, 1, 2, 3, 4, 5 to the following 1, 2, 3, 4, 5 standards. So a different volumetric pipette will be used for each of those. Now, the chemical ammonium acetate, 1 milliliter is being added. Well, 1 milliliter is being added to all of the solutions. So a new 1 milliliter pipette that is different from the 1 milliliter pipette being used for iron, so it's a fresh 1 milliliter pipette, can be used to add the 1 milliliter of ammonium acetate, and then that same pipette can add 1 milliliter of ammonium acetate to the next one on down the assembly line. Okay. It's going to be important that you keep track of how many of each size volumetric pipette you need. That'll be a thing that will be important for your material sheet. Okay. So when adding these chemicals, so one partner adds the iron to all of them, and then the other one adds the ammonium acetate, and then the next one adds the hydroxylamine hydrochloride, and then the next one adds the O-phenanthrene. At some point, a visible color will become apparent in standard 1, 2, 3, 4, and 5, but there will be no visible color in the blank. Okay. So you'll be able to see a color right away, but the problem is this reaction is actually a relatively slow reaction, so the color is not finished developing for at least 45 minutes. So once these 4 chemicals, iron, ammonium acetate, hydroxylamine hydrochloride, and O-phenanthrene are added, you should, you don't have to start a stopwatch, but you can either start a stopwatch or make note of the time. These 4 chemicals have to sit for at least 45 minutes together before we can test them. Now, when you add these chemicals, all 4 chemicals, the volumetric flask is not going to be full. It's going to be just a small amount of chemical there because we're adding not very much of each of them. So at some point, deionized water needs to be added to these volumetric flasks until it's on the line, and then the cap added and then inverted. The water doesn't have to be there for the 45 minutes to start. So my suggestion is going to be to add these 4 chemicals to all 6 volumetric flasks. And then in part B, we're going to be doing this reaction again. So don't add the water to those volumetric flasks yet. Instead, move on to part B until you can mix all the chemicals together, and then come back during that 45-minute wait, once you've gotten everything made, to add the water and put the lids on and invert them. That is the most efficient use of your time. Okay, so I would say you're going to make your 6 solutions in part A, pipetting the 4 solutions into each. You can even put the lids on them to keep them safe and set them aside, knowing that you'll be coming back and adding DI water later. But before you add the DI water, go on to part B and start working. So in part B, we're going to be making more solutions with iron, but this time they will be with an unknown iron solution. Okay, the unknown iron solution has not been made for you. You're going to have to make it yourself, starting with an unknown iron solid. So record the unknown number that either your instructor gives you or that you have selected, and then you're going to be adding this solid directly into a brand new, clean, not one of the same flasks you've already used, 50 milliliter volumetric flask. So we're going to be adding the solid directly into the volumetric flask. So you're going to place the volumetric flask on the balance, close all the doors, tear the balance so it says 0.0000, take a metal scupula, and you're going to carefully transfer the solid from the container that the unknown solid is in directly into the volumetric flask. The lab says to add about 0.1 grams. It needs to be at least 0.1. So kind of somewhere between 0.1 grams and 0.15 grams is what I would suggest. So add the solid, then once it's within that range, close the doors, record the mass very carefully. Okay. So that solid we're going to need to dissolve. And what we're doing right now is making this unknown standard. So I would actually take a Sharpie marker and write unknown standard down on the outside of this volumetric flask. Once the solid is in there and you've recorded the mass and you've labeled your flask, you're going to walk over to a fume hood wherever the 6 molar sulfuric acid is kept in the room, and you're going to add 5 drops using a disposable pipette directly on top of the solid. Okay. Do not pour the sulfuric acid into a beaker. Don't bring the sulfuric acid back to your station. You're going to go to the sulfuric acid. You're going to use the pipette that's there, and you're going to add 5 drops to it, put the pipette back, and walk away. Okay, you're not taking the acid with you. We don't want, 6 molar is very strong. It's not the strongest it can be, but it's strong enough that you're going to feel significant burning on your skin if this sulfuric acid gets on your skin. So we're wearing our gloves, and we're going to minimize our contact with the sulfuric acid. Okay, so you'll add your 5 drops, go back to your lab station, and then what we need to do now is add DI water to this. And so we're going to add deionized water to our flask until, oops, I'm spilling, until it's about halfway full. Okay, maybe even a little bit more than halfway, but definitely not to the neck yet. And then you're going to swirl until the solid dissolves. Once the solid is completely dissolved, finish adding the DI water until you get it right on the line. Add the lid, invert it multiple times. So this unknown standard solution you're going to use to create 3 more solutions in part B. Okay. So these other 3 solutions are going to be called unknown dilute solutions. So the one with the solid is the unknown standard solution. It will not have a color. It's just going to look like clear, colorless liquid, just like water. Well, it's not just water. It's water, unknown that contains iron, and the 6 molar sulfuric acid. Okay. But in the data table for part B, where it asks you to make the unknown dilute solution 1, 2, and 3, the unknown standard solution is mentioned. That is going to be the solution that you made yourself out of the solid. Okay. So the lab tells you to make 3 solutions that are actually going to be identical to each other, adding 1 milliliter of the unknown standard. So this will be needing a brand new 1 milliliter pipette because you have not yet used unknown standard. So fresh 1 milliliter pipette. But then it has you add ammonium acetate, hydroxylamine hydrochloride, and O-phenanthroline. All of these 3 chemicals you added in part A. You already have pipettes that you've conditioned and have this chemical in them. So you can use the same pipettes from part A as part B for those 3 chemicals, not for the unknown standard because it's a new chemical. Once you mix these 4 chemicals together, the unknown standard and then the other 3, you're going to see a visible color start to form. And these 3 solutions have to also sit for 45 minutes. You will have to, in that 45 minutes, add DI water to them, put the lid on them, and mix them. But what I would have suggested is that at this point, you added the 4 chemicals together to the 6 flasks in part A. Make the unknown standard with the solid, the acid, and the DI water. Use the unknown standard to make the 3 unknown dilute solutions by mixing the 4 chemicals together. Once you've done all of that, now go back, take your DI water, your disposable pipette, and fill all of the volumetric flasks that you've made up to the line, put the lid on them, and invert them. So that way, because you have to wait until all of the solutions have set for at least 45 minutes before you can test them. So you can add the water while you're sitting for 45 minutes, and then you won't actually have very much time of waiting around. Okay. So once it has reached 45 minutes, and you've added DI water to all the flasks, and you've put the lids on them, and you've mixed all of the flasks at least 10 times, then you're ready to use the spectrophotometer. Okay. So the spectrophotometers will be at your station, and you'll either have an old spectrophotometer or a new spectrophotometer. If you're not sure which one is which, ask me, but usually it's pretty obvious by looking at it. The old ones were made in 1989, I believe, and the new ones are all less than 5 years old. So one of them has a rolling knob, and the other one has digital buttons. So I think you're going to be able to tell. Next to that, you'll have there'll be a box of cuvettes. They'll either be glass, if it's an old spectrophotometer, so they're made of glass and look kind of like test tubes, or they'll be made of plastic if you have a new spectrophotometer. Take out one cuvette, and that will be the one cuvette you use for the entire experiment. Okay. You will need to set your instrument, your spectrophotometer, to a wavelength of 510 nanometers, and you can look in part C of the lab on how to do that, depending on if you have an old or a new spectrophotometer. And then we need to blank the spectrophotometer. So our blank for this lab is not going to be deionized water. It's going to be the solution that you made in part A, labeled blank. So you're going to take your empty cuvette, pour your blank solution in, and then dump it into the waste beaker a second time, a third time, and then the fourth time, once you fill it at least halfway up, get a Kim wipe out of the Kim wipe box, wipe the cuvette down, insert it into the spectrophotometer, close the lid, and then follow the instructions in part C on how to blank it. It'll either be pushing a button or rolling a knob to get it to an absorbance of 0.000. Once you've done that, dump the blank into your waste beaker. Take standard 1, condition it 3 times. So fill it up, dump it in the waste beaker, fill it up, dump it in the waste beaker, fill it up, dump it in the waste beaker, fill it up a 4th time, wipe out the Kim wipe, insert it into the instrument, and record the absorbance. We'll do this again for standard 2, standard 3, standard 4, standard 5. Condition the cuvette 3 times with the new solution before you measure it. We got to rinse out the old solution, make sure it's gone before we make our measurements. So that will take care of your data in part A. After you've finished part A, where you've done blank, standard 1, standard 2, standard 3, standard 4, standard 5, then you're going to take the blank solution and use it to blank the solution again. So you're going to dump out standard 5, pour in the blank, dump it, pour in the blank, dump it, pour in the blank, dump it, pour in the blank a fourth time, wipe it with the Kim wipe, put it into the instrument, and re-push the button or rolly the thing to set it to 0. After you've done that, you're now ready to test the 3 dilute solutions from Part B. You actually made 4 solutions in Part B. One of them was the unknown standard. It doesn't have a color. And then the other 3 were the unknown dilute solutions. They will have that orange-red color. Those are the 3 that you're testing. In Part A, your absorbances should have went up from standard 1 to standard 2 to standard 3 to standard 4 to standard 5 because we added more iron as we went down the list. In Part B, the unknown dilute solutions, we did the exact same thing to them. So their absorbances should hopefully be the same or at least very close together. Okay. So after you blanket between Part A and Part B, then test unknown dilute solution 1, then 2, then 3. Record the absorbances after conditioning it 3 times. At that point, you will have your data recorded. So that will include the absorbances from Part A, the absorbances from Part B, and the mass of the unknown in Part B. The rest of the lab are calculations. So let's talk about cleanup. The volumetric pipettes will all be placed in a labeled cylinder for volumetric pipettes. You're not washing these, you're just putting them away. The cuvettes, if you have an old spectrophotometer with a glass cuvette, you're going to wash the cuvette and put it back in the styrofoam box. If you have a new spectrophotometer with a plastic cuvette of some type, you're going to put that in the broken glass box. They don't clean up very well, so we throw them away when we're done with them. I know this is plastic, and I'm telling you to put it in the broken glass box, but when this breaks, it's very sharp, so it's kind of like we're putting it in the sharps box, which is where the rest of the glass is. And then the plastic disposable pipettes that you use to dilute the volumetric flasks to the line get thrown in the trash can. Everything else we're going to wash and put away. Combine all of your leftover chemicals into one waste beaker. Honestly, I would suggest making it a 1-liter beaker just to make sure that you know that you have enough space. So you can get out that 1-liter beaker at the beginning of lab and put all of your chemicals in it as you condition and as you finish them. So you're going to combine all the chemicals into this 1-liter beaker. Those chemicals are going to be acidic because we added 6 molar sulfuric acid to things, plus some of the other chemicals are acidic. Before those chemicals can be dumped down the drain, they have to be neutralized. They're going to be neutralized using solid sodium bicarbonate, baking soda. So you're going to add the baking soda using a glass stir rod to mix it and pH strips to test it until the pH of the total mixture is 6, 7, 8, or 9, and then you're going to pour it down the drain. There's a separate video showing you how to neutralize acidic solutions using sodium bicarbonate, so check that out if this is not something that you have done before. Once it's neutralized, you'll pour it down the drain and then wash all of the glassware, soap, water, rinse it with GI water the last time, and put it all away. So for more information on the calculations and post-lab questions and information about that, check out the calculations in lab and theory video.